Hello everybody, this is Biswajoy Chatterjee, Vice Chancellor, University of Engineering and Management, UEM Jaipur. So today I'm back again with another puzzle, which is the 12 coins problem. So as you can see in my screen now, the 12 coins problem. So what does this problem state? It states that you were given a weigh scale, a weighing machine. It is quite similar to an old puzzle that I had done prior to this, which was the 8 balls and a weigh scale. It is almost similar, but here with 12 coins, and there are certain differences. So let me start without any reference to any other puzzle. Let me treat it as a new puzzle. You are given a weigh scale. And what is a weigh scale? Something which looks like this. You are given a weigh scale like this. So you can measure weights relative to one another using this weigh scale. And you are also given 12 coins. 12 coins. And the information is one of these coins is faulty. That is either heavier or lighter than others. So it is expected that 11 coins are absolutely equal or same in weight. And one coin is faulty, which is heavier or lighter than the others, but you don't know which one is faulty and you don't know whether it is heavier or lighter. So what is the challenge? How many weighings will you need to tell which coin is faulty and whether it is heavier or lighter? 12 coins are there. You will have to tell me which coin out of this 12 is heavier or lighter, all other 11 being equal in weight. How many weighings will you need to tell that which coin is it and whether it is heavier or lighter? You can pause it over here and give it a thought. Think, how many weighings will you need? I tell you, it can be done within 3 weighings. But how? That is the challenge. So try it yourself first. You can pause the video once and try it, but I will continue. See, if you divide it into 6 and 6, say, I just take it. Suppose you divide the coins into 6 groups of 6. That is half. 6 over here and 6 in the other coin, other group. Then suppose you measure first 6 in the weigh scale, dividing it again into 3 and 3. Suppose they measured the same, then you are left with 6 coins to know that which one of this is heavier or lighter. Suppose this 6 measure the same, you divide them into 3 and 3 and measure in the weighing scale, and you find that they are same. Then you are left with this 6, in which the question is which one is heavier or lighter. Can it be done in rest 2 weighings? Difficult. So the solution is somewhat different. I come to the solution now. So for the solution to be done, I explain it like this. Let us number the coins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. As you can see, 12 coins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I firstly choose 8 coins out of this. That is, I choose these 8 coins and I don't use these 4 at the initial stages. I do not use it at the beginning. Only 8 of them I choose initially. What will I do? I will put them into the weighing scale, dividing it into groups of 4. That is, say suppose I divide it into 1, 2, 3, 4 and 7, 8, 9, 10. So 1, 2, 3, 4 on one side of the weighing scale, 7, 8, 9, 10 on other side of the weighing scale, and leaving out 5, 6, 11, 12. So let me put it on 2 sides of the weighing scale. Suppose they weigh the same. You might tell, no, they may not also weigh the same. Yes, that is another case. I will treat it as a separate case and tell you. But if they measured the same, then what? Let us take this first case as the case 1. Let us take this as case 1, that these 8 coins measure the same, 4 each on 2 sides of the weighing scale. What can you comment immediately? You can comment that these 8 coins are proper, because had the faulty coin, had the heavier or the lighter coin been present within 1, 2, 3, 4, 7, 8, 9, 10, then one side of the weighing scale would have gone down and the other side would have gone up. But they are on the same level, showing that they measured the same. So all these 8 coins measure the same. So that one coin which is faulty is definitely not present within 1, 2, 3, 4, 7, 8, 9, 10. So where is the faulty coin? Definitely the faulty coin is 1 out of 5, 6, 11, 12 in this example. Definitely it is 1 out of 5, 6, 11, 12. So the faulty coin lies there. So how to know which one is faulty? You have already done first weighing. You are left with 2 weighings to determine which out of 5, 6, 11, 12 is faulty. And that also you don't know whether it is heavier or lighter. So what to do? Dividing it into groups of 2 won't help that much, because you have to do it within 2 weighings where you don't know whether the faulty coin is heavier or lighter. Let us do one thing. I know this much, that 1, 2, 3, 4, 7, 8, 9, 10 are proper coins. And I know that 5, 6, 11, 12, the faulty coin is 1 out of this. What I do is, I choose 3 proper coins, say 1, 2, 3. I choose 3 proper coins, say 1, 2, 3, any 3 proper coins. It can be 1, 2, 3, it can be 4, 7, 8, it can be 8, 9, 10, it can be anything. 3 proper coins randomly I choose, and also 3 coins which I doubt, leaving out 1 doubtful coin. There are 4 doubtful coins, 5, 6, 11, 12. Say I choose 5, 6, 11, 3 doubtful coins and 3 proper coins. So the next step is, I take 1, 2, 3, 1 on one side, 3 proper coins on one side, 5, 6, 11, the 3 doubtful coins on the other side. So check this. I know 1, 2, 3 are proper, so the tick mark is there. And I know 5, 6, 11 is doubtful, so the question mark is there. So 3 coins doubtful and 3 coins proper. What to do? Put it on 2 sides of the weighing scale. Suppose they weigh the same. Again, you may object, saying that, but they might not have weighed the same. Yes, that is again another case. I will take that case also. But suppose in case 1, I assume that 1, 2, 3, 5, 6, 11 measure the same. Then what? Then you immediately know that 5, 6, 11 are also proper, because had the faulty coin been 1 out of 5, 6, 11, had the faulty coin been 1 out of 5, 6, 11, then this side of the weighing scale should have either gone down or gone up. But they measure exactly the same as that of 1, 2, 3. So the faulty coin is not within 5, 6, 11. So the faulty coin is what? The faulty coin is definitely 12, because 1 out of 5, 6, 11, 12 is faulty. That you had already commented, we had already determined that yes, 5, 6, 11, 12, one of them is definitely faulty. So that we had concluded earlier. So you can now say that was your second weighing. 1, 2, 3, 5, 6, 11, they are proper, and 1 out of 5, 6, 11 and 12 is faulty. So definitely 12 is faulty. But wait a minute. Yes, it is faulty, but is it heavier or is it lighter? How can you measure that? It's very easy. Now you measure 12 against any of the other 11 proper coins. You know 12 is faulty, but 1 to 11 all are proper. Choose any proper coin out of 1 to 11 and measure 12 with it to see whether 12 is lighter or heavier. If 12 is lighter, weighing machine will show. If 12, weighing scale will show. If 12 is heavier, that also weighing scale will show. So you measure 12 against any of the other 11 proper coins to know whether it is heavier or lighter, and that was your third weighing. So you have now measured which coin is faulty, and also you have said whether it is heavier or lighter within 3 weighings. But as we said, this was your case 1. See, I have written over here. This one is your case 1 now. But things might not have progressed this way. This could have been the case. That is, here where we assume that they weigh the same, maybe they did not weigh the same, then these few steps would not have been there. These few steps would have vanished. So these few steps would have vanished, and you are left with this going towards case 2, where 1, 2, 3, 5, 6, 11 measure differently like this. See, I revise once more the case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 coins. You have chosen 8. 1, 2, 3, 4, 7, 8, 9, 10. Put them on two sides of the weighing machine. Suppose they weigh the same. That was your first weighing. So 1, 2, 3, 4, 7, 8, 9, 10 are proper coins. 5, 6, 11, 12, they are faulty coins. One out of them is a faulty coin. One out of them. You have left out 1, 2, 3, 4, 7, 8, 9, 10, knowing that they are proper coins. So the faulty, the doubtful coin is only over here. This is your question. Now what to do? What to do is you take 1, 2, 3, any three proper coins, as I've said already, any three proper coins and any three doubtful coin, and put them on two sides of the weigh scale. Suppose they weigh differently. Suppose 1, 2, 3 weigh more and 5, 6, 11 weigh lesser. You immediately know that the faulty coin is within 5, 6, 11. 12 is proper. You immediately know that 12 is also proper. Like 1, 2, 3, 4, 7, 8, 9, 10 are proper, 12 is also proper, because the faulty coin is present within 5, 6, 11. And also you know that one out of these 5, 6, 11 which is faulty is also lighter, because it has weighed less. Had 5, 6, 11 weighed heavier, then also it is the same case. 5, 6, 11 also could have weighed heavier. Then we would have concluded that the faulty coin is within 5, 6, 11, and yes, that is heavier. So 5, 6, 11, one of them is faulty and it is lighter. Now what to do? That was your second weighing. So in one weighing you will have to tell which out of 5, 6, 11 is lighter. Second weighing done. Faulty coin is 1 out of 5, 6, 11 and it is lighter. Weigh any of these two. What is the next step? 5, 6, 11, one of them is lighter, you know. What to do? Weigh any of these two. Suppose you choose 5 and 6 and weigh them. If they measure the same, then 11 is lighter. 11 is faulty and lighter if they measure the same. You choose 5 and 6, measure them. If 5 and 6 weigh the same, then 11 is lighter. If they don't weigh the same, then you are already seeing the lighter coin in the weigh scale. So here it is, weigh any of these two. This is your third weighing, where if they weigh the same, the one not weighed is lighter. If these two weigh the same, 5 and 6, then definitely you know 5 and 6 are proper. So 1 out of 5, 6, 11 is lighter, so 11 is lighter. But if 5 and 6 don't weigh the same, say 5 weighs lighter, you immediately say that 5 is lighter, because you know that the lighter coin, the faulty coin, is lighter. So here also you have solved in how many chances? In 3 chances or 3 weighings you have done that. But again this was your case 2. There can be another case also, a case 3, where this weigh same. Look over here, this might not have weighed the same. So have a look there. Suppose this did not weigh the same, then what? Your third case now begins, where all these cases will not be like this, all these steps will not be like this, so they vanish. You are over here, where you have chosen 1, 2, 3, 4, 7, 8, 9, 10 to measure which coin out of these 12 coins is faulty and whether it is lighter or heavier. You choose 8 coins, put them on two sides of the weigh scale. Suppose they don't measure the same. Say 1, 2, 3, 4 is heavier and 7, 8, 9, 10 is lighter. What do you comment now? You immediately comment 1, 2, 3, 4, 7, 8, 9, 10. One out of these 8 coins is faulty. So you don't know that the coin is heavier or lighter. So definitely you don't know which out of 1, 2, 3, 4, 7, 8, 9, 10. But you know that one out of these 8 coins is faulty and the other 4, that is 5, 6, 11, 12, they are proper. That's what I comment. 1, 2, 3, 4, 7, 8, 9, 10 now in question. That was your first weighing, and you say faulty coin is 1 out of 1, 2, 3, 4, 7, 8, 9, 10, and 5, 6, 11, 12 are proper. So now how to find that which out of 1, 2, 3, 4, 7, 8, 9, 10 is faulty? What will you do now? What you do is very simple. See what you do. Choose 2 coins from heavier side and 1 coin from lighter side and put it in one side of the scale. Say you choose 2 coins from heavier side. So 2 coins from heavier side. See 1 and 2, 2 coins from heavier side I have taken. And 1 coin from lighter side. See 1 coin from lighter side. Put it in one side of the scale. So one side of the scale, what will it contain? One side of the scale will contain 1, 2 and 7. Then what? The 2 other coins from heavier side and 1 other coin from lighter side. Put it in other side of the scale. That is 2 other coins from heavier side. The 2 other coins from heavier side. And 1 other coin from lighter side. 1 other coin from lighter side. So you choose 3, 4 and 8. 2 other coins from heavier side and 1 other coin from lighter side, and put it on other side of the scale. So what you do is 1 to 7 on one side, 3, 4, 8 on the other side. 1, 2, 3, 4, 7, 8, 9, 10. What you are doing? See, 1, 2 and 7 on one side, 3, 4 and 8 on the other side. See, that is what I was doing. So 1 to 7 on one side, 3, 4, 8 on the other side, and you measure. Suppose they weigh the same. Remember, you have left out 9 and 10. Remember, you have left out 9 and 10. 1 to 7, 3, 4, 8. Suppose they weigh the same. You might again say, if they did not weigh the same, yes, that is another case, case 4. But here, I assume they weigh the same. And you can immediately comment, because they weigh the same, 1 to 7 and 3, 4, 8, the proper coin is, they are all proper coins, and you can immediately leave them out. So your doubt was with 1, 2, 3, 4, 7, 8, 9, 10, out of which 1 to 7, 3, 4, 8 are proper. So where is the doubtful coin? The doubtful coins are only 9 and 10. So you know 1 out of 9 and 10 is faulty, and that also you know that it is lighter. Had that happened, that 1, 2, 7, 3, 4, 8, 9, 10 is on the lighter side, you can immediately comment that yes, 9 and 10, 1 out of 9 and 10 is faulty, and that 1 out of 9 and 10 is lighter. So which out of 9 and 10 is lighter? That is the only question left now. But your second weighing is done. So how to use the third weighing to say which out of 9 and 10 is lighter? Very simple. You know, leaving out 9 and 10, all other 10 coins are proper. So 1, 2, 7, 3, 4, 8 are proper coins. 5, 6, 11, 12 are also proper. So this 6, this 4, these 10 coins are proper. So measure 9, and 9 and 10, one of these 2 coins is faulty and it is lighter. What will you do now? One out of these 2 coins is faulty and it is lighter. 1 out of 9 and 10. What do you do? Measure 9 against any of the proper coins 1 to 8 or 11 to 12. You measure 9 against any of the proper coins 1 to 8 or 11, 12. You measure 9 against any of those. If this was your third weighing, don't forget. If they measure same, 10 is lighter, because 1 out of 9 and 10 is lighter. 1 out of 9 and 10 is lighter. So you measure 9 with any of the proper coins. If they measure the same, 9 is proper, so 10 is lighter. Otherwise, 9 definitely is lighter. If they don't measure the same, 9 will measure lighter, because you know one of these 2 coins, 9 and 10, is lighter. So here also it is solved in how many weighings? Done again in 3 weighings. But the final thing, that is, suppose this way same would not have happened, then these steps would have all vanished. See, and you are left with, left over here, where your case 4 is exactly this. See what is your case 4. You were given 12 coins, you chose 8 of them, put them on the weighing scale, 4 each side. One of the sides measured heavier, that was your first weighing. You commented one out of these 8 coins is faulty, the other 4, 5, 6, 11, 12 are proper. Choose 2 coins from heavier side, 1 coin from lighter side, put it in one side. So 1, 2 and 7 on one side, and 2 coins from the heavier side, 2 other coins from heavier side, that is 3, 4, and 1 other coin from lighter side, 8 on other side of the scale. So 1, 2, 7, 3, 4, 8 you have put, and one side weighs heavier. Say one side weighs heavier. Do you understand this? 1, 2, 7, 3, 4, 8 you put, and one side weighs heavier. Remember, you have left out 9, 10. Because one side weighs heavier, you immediately know 9 and 10 are proper now, and the faulty coin is 1 out of 1, 2, 7, 3, 4, 8. So 1, 2, 7 weighs more, suppose. So 1, 2, 7, 3, 4, 8 are the only coins in question. Now this was your second weighing. So which out of 1, 2, 7, 3, 4, 8? How to go ahead? Faulty coin is 1 out of 1, 2, 7, 3, 4, 8. 9 and 10 are proper. How to go ahead now? See, how to go ahead is very interesting. I will tell you. I'll just try to explain to you like this. Assume 7 is the faulty coin. Please, for the understanding sake, let us assume, say 7 is the faulty coin. The approach is, I will assume 7 to be faulty coin and show that it is not possible. See, assume 7 is the faulty coin. So if 7 is the faulty coin, maybe 7 is either heavier or lighter. So if 7 is heavier, say 7 is heavier. If 7 is heavier, 7 could not have been in the lighter side over here. In this weighing, 7 could not have been in the lighter side if 7 would have been heavier. So 7 is definitely not heavier. Say 7 is lighter. Say 7 is lighter. If 7 is lighter, 7 could not have been in the heavier side over here. 7 could not have been in the heavier side over here. So 7 is not lighter. So 7 cannot be heavier because here 7 is on the lighter side. Here 7 is on the lighter side, so 7 cannot be heavier. 7 cannot be lighter because here 7 is on the heavier side. So 7 is not heavier, 7 is not lighter. So 7 is proper. Leave out 7. You are left with 1, 2, 3, 4, 8. Now assume 1 out of 1, 2, 3, 4, 8 is fault. 1 out of 3 and 4 is lighter. Assume 1 out of 3 and 4 is lighter. If 1 out of 3 and 4 is faulty and say it is lighter, then 3 and 4 could not have been in the heavier side over here. If 1 out of 3 and 4 is lighter, 3 and 4 cannot be in the heavier side over here. If 1 out of 3 and 4 is heavier, then again 3 and 4 cannot be in the lighter side over here. So see what? 3 and 4, 1 out of 3 and 4 cannot be heavier because here it is on the lighter side. 3 and 4, 1 out of 3 and 4 cannot be heavier because here it is on the lighter side. 1 out of 3 and 4 cannot be lighter because here it is on the, because here both of them are on the heavier side. So 3 and 4 are not lighter. 1 out of 3 and 4 is not lighter. 1 out of 3 and 4 is not heavier. So 3 and 4 are proper. So 3 and 4 gone. You are only left with 1, 2 and 8. So remember, here 1 and 2 are on the heavier side. Here also 1 and 2 are on the heavier side. So either 1 out of 1 and 2 is heavier or 8 is lighter. See, here 8 is on the lighter side. Here also 8 is on the lighter side. So you are only left with 1, 2 and 8. You can comment either 1 and 2 is heavier. Either 1 out of 1 and 2 is heavier or 8 is lighter. See what I said? Either 1 out of 1 and 2 is heavier or 8 is lighter. So I've written this whole thing. If 7 is heavier, then in the previous weighing 7 could not have been in the lighter side, and if 7 is lighter, then in this weighing it could not have been in the heavier side, so 7 is not faulty. Similarly, if 1 out of 3 or 4 is lighter, then in the previous weighing 3 and 4 could not have been in the heavier side, and if 1 out of 3 and 4 is heavier, then in this weighing it could not have been in the lighter side. So 3 and 4 are not faulty. So what to do? How to know that 1, 2 and 8, which out of 1, 2 and 8 is the one? Either 1 or 2 is heavier. So see, either 1 or 2 is heavier, because in both weighings they are on the heavier side, or 8 is lighter. This much you are sure. What to do? Measure 1 against 2. Measure 1 with 2. If one of them shows heavier, you have got the heavier coin. You measure 1 with 2. If one of them shows heavier, then you have got the heavier coin. If they weigh the same, 8 is lighter. So here is your third weighing. Measure 1 with 2 and see if any of these measure heavier, heavier coin is found. You are measuring 1 with 2. You know one of them can be heavier. So if one of them shows heavier, then you know you have got the heavier coin. But if they weigh the same, you know that 8 is lighter. So you have got the solution again. In how many weighings? In 3 weighings. So your job is again done now. You have solved the 12 coins problem in 3 weighings, and that was your only target. So as I can say that the job ends over here. The job ends over here for others, but for the programmers will definitely now try to write a program either in C or in Java or in Python or in C++, hardly matters, will write a program to accept the weight of 12 coins and print the steps which will detect the heavier or the lighter coin. So thank you so much. I thank you all for listening to this. On behalf of Biswajoy Chatterjee, I'm the Vice Chancellor of University of Engineering and Management, UEM Jaipur. I thank you all. Thanks.